Mighty God, thank you for today. Thank you for the gift of life. Thank you for this lesson you are going to. Lord, we want to pray that you may bestow your spirit of understanding upon us. Help us to get every concept from the teacher and help him to teach us what is right. In Jesus' mighty name, I prayed and believed. Amen.
Amen. I'm not going to mute you for now. There I will mute you. I want to first take you for what I shared. Okay. That is where I wanted us to start from. And I'm going to ask you to share in the chat any physics concept you have observed or you have thought about. Just in the chat, any physics concept that has come to your mind relate the topic we are covering. Any. Feel free to share in the chat anything. Okay, good. Good. People are saying motion. People are saying speed. Okay, good, good. Share anything. For you, anything that has come to your mind, what you have observed. Yes. Okay, good. I'm saying many answers are coming in. That is very good. That is very good. Okay, 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 okay. That is perfect. That is perfect. Okay. Perfect. 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 Okay. Thank you for sharing all those answers.
So you're not audible.
Oh, okay. What about now, Van?
At least
You are
better.
able better. Okay. I think let me. Okay. Okay. Now I've seen all the answers, and what you are sharing in the chat is actually what we are going to be looking at. Today, I want to test your discipline to check whether people can. I'm not going to I'm going to leave everyone unmuted, and then we check out whether people are really disciplined and they can manage themselves. Okay, that is really very good. Thank you for sharing. Now, last time we looked at something, and I thought I needed to launch something. So I want you to look at your screen. Look at your screen. There is something that is going to appear. Is there something appearing on your screen?
Yes.
So can we quickly attempt? Look at your screen and kindly attempt.
I'm not saying anything.
Really?
Yeah.
Members, are we seeing something?
No.
No, nothing. Anyone was seeing something?
Yeah, I've seen something.
Okay,
I have seen.
What are you seeing?
Physics poll.
Quiz.
Yes. Yes. Now, those people who are not seeing, I think those are people who are using phones. Kindly check. I'm trying to check my phone. But it is appearing.
It's not.
No, just go on.
Just go on. Okay. Okay, give me a minute. Okay, give me a minute. Let me launch it again.
So it has disappeared.
Mine too. It's appearing.
Disappeared.
Okay, sorry.
Disappeared.
Okay. Let me launch it again, yeah? I'm launching it again.
Okay,
Okay.
teacher.
Okay.
I'm trying to see that.
Please.
Okay. Let's just, I'm trying. Okay. My poll is a bit inactive. I don't know, but I think I will. Okay. Now, since I've tested your in order for us to have a good class, I think it is better I mute you because we may fail. We may fail to coordinate. Okay, so I wanted to launch that poll, but don't worry. I'm going to launch it at some time to come because it has disappeared. So today we are looking at physics. Those who have just joined us, thank you so much for coming. Sorry. So we are going to look at physics. Our concept that we are going to look at is here on the screen. So I started with those cars to show you different things. One of them was to show you, people mentioned in the chat that there was some kind of speed. You saw how people were really connecting, negotiating corners. So you notice that when someone reaches a corner, he has to reduce on the speed. Let me also first disable this. So someone has to first disable to have a low speed such that he can be able to negotiate the corner. So that is what we are going to mainly look at in our today's lesson. Now I want you to look at the picture that I have displayed and look at it critically. There are 4 vehicles in the picture. I want you to look at the picture and look at 3 things. I want you to look at the distance and look at the time and make your observations and then raise up your hand. Look at mainly the 3 vehicles, look at the distance and look at the time and tell us which kind of relation are you noticing. Look, Tasha?
When at time 0 to time 1, like the distance covered is okay, like the distance covered is kind of like less than the one covered from time 1 to time 2. Then even the one from time 2 to time 3 is also less. So meaning at the beginning, he was like the distance covered in that time was less. And also in time, so meaning I think the person driving had reduced the speed, and then when he started, he increased, something like that.
Okay, thank you. Prime, that is good. Thank you, Tasha.
So I am noticing that the distance is increasing and the time is also increasing. So it means that the person's speed is also increasing, because at time 0, the distance is shorter, but the more he moves, the distance increases as the time also increases.
Okay, okay. Now okay. Yes, is it check something like that? Davinia, yes.
Yes, teacher. So what I'm seeing at time 0 to time 1, the distance is 0. But as the time increases, the distance also increases, which means that distance is directly proportional to time. Thank you.
Okay, okay, thank you. Now, I'm putting some letters, and I want you to tell me in terms of speed. I've put letter A, letter B, and letter C. I want you to check out and tell me whether the speed is the same in A, B, and C. And if at all it's not the same, why do you think so? And what are you basing on to say that here the speed might be small, here might be big? Raise up the hand and you tell us your observation. Between A, B, and C, where do you think the car is using more speed? Where do you think it is small? Okay, again, Tasha.
B, the car is using more speed. Then A, it's using A and B. I mean A and C, I think it's using the same speed, but B, it's using a higher speed.
Okay, what do you base on? Why?
I don't know.
Okay, it is okay. Then Gladish.
So I think B, the car is using more speed than A, because if you're to see B, the distance is somehow larger than A and C.
Okay, thank you. Hitha. Kea.
I think B
Hmm.
moved at a longer distance than A and C. If you look at their distance, it shows that the speed that they used is different, based on also their time zones that they are in. So
Okay,
that,
good.
depending on the time that they are moving at. So B moved at a higher speed than A and C due to the distance that is shown and the time. So B and C, they look like they traveled at the same distance, though their time is different. That's what I think.
Okay, thank you so much for sharing. Now you're going to note that when you are traveling from one place to another, whenever a vehicle is moving from one place to another, always its speed changes. Whenever you are traveling, those people who have been to mountainous areas, take an example, those ends of Chisolo, those ends of Kabale, Kapchora. Whenever you are traveling, your speed can never be the same. Why? You keep on rotating. Those people who have been to Chisolo, all those areas, you notice that you are climbing a mountain, rotating around. And if you are negotiating a corner, the speed you are using to move on a flat land, it cannot be the same speed you will use when you are moving around a corner. And therefore, it means that at every particular point or distance that you are going to cover, you may find yourself that you are changing the speed. But when you are traveling on a flat land, you can have the same speed. But when you reach where there is traffic jam, your speed will change. When you reach where there is no traffic jam, you'll find yourself increasing. And you have seen your parents. When they are traveling in areas where there is no traffic jam, they drive even at 180 kilometers per hour. But when they meet an area where there is jam, you see them slowing down. And therefore, that shows us that speed can keep on changing depending on the situation, depending on the distance. And therefore, that concept of changing the speed at given areas is what we refer to as average speed. Now, let me ask in the chat, tell us how you understand by average speed. Yeah, you can use the chat. Feel free to type in what you understand by average speed. I want to read one answer. Okay. Okay. The speed that is being used throughout the journey. Very good. That is true. Yeah. But okay. So, okay, as you are typing and thinking, I'm going to ask you now to write our heading. So today we are going to start with what we call average speed. So you write your title speed. Okay. So those people who have just joined us, we are covering the topic of motion. Mega, Agatha, and Daniel, they're saying average speed is that total distance you cover in a particular time interval. Good. Prime is saying the total distance out of total time. Alan is saying distance covered by a moving body throughout the journey. Total distance covered divided by the total time taken. Okay, good. So hope we have finished right our heading. Our heading is average speed. Hope everyone has finished right. Now, when we talk about average speed, we are looking at the distance you cover in a particular time interval. How much distance do you cover? Divide by the time you take to cover it. You can find yourself that when you are moving, let me use the areas. Someone is moving from Kampala going to from Kampala, you are going to Mukono, and then this person reaches Mukono, he turns, he moves along Kayunga Road. From Kampala to Mukono is roughly about 20 kilometers. From Mukono to Kayunga, it's roughly about 30 kilometers. But you are going to find that this person, when he's moving from Kampala to Boyogere, because of a lot of jam, this person may use about 2 hours to move from Kampala to Boyogere because of a lot of jam around that area. So that time will be 2 hours. You find that to move from Boyogere to Mukono, this person is using 3 hours. Why? When this person reaches Seta, there is jam. He reaches Mukono there is a lot of jam. Then this person from Mukono to Kayunga, since this road is a free road, there is no jam. The jam is minimum. So you find him that to move from Mukono to Kayunga, this person is just using just 1 hour to move from there. The distance of 30 kilometers is using 1 hour. And the distance of 20 kilometers, he has used about 5 hours. So average speed, we are asking yourself that for this person moving from Kampala to Kayunga, what is the average? Average is like, what is the mean speed that this person has used? So in order for us to obtain that mean speed that this person uses, we always get the total distance that this person has covered. So when you look, let me ask those people who are really following up, what is the total distance from Kampala to Mukono? Use the chart. From Kampala to Mukono, what is the total distance? Yes, I'm checking. What is the total distance from Kampala to, Kampala to Kayunga? That's my question. Someone moving from Kampala to Kayunga, what is that total distance? Emily is saying 50. Very good. Very good. So your total distance is going to be the 20 plus the 30. That is the total distance. The 20 from Kampala to Mukono and from Mukono to Kayunga, which is 30, which is very good, 50 kilometers. Now my next question. What is the total time taken? What is the total time taken to move from Kampala to Kayunga? Type in the chat. To move from Kampala to Kayunga. Someone is saying 6 hours, 6 hours, 6 hours, 4 hours, 6, 6, 6. 6, 6, 4. Oh, some are saying 4. Some are saying 4. Okay, I think people were mentioning 6. They are very correct. Why? Someone to explain, to bring people who are saying 4 on board. Who wants to bring the people? Samsung. Who is Samsung? Oh, Samsung is off. Will Faith.
Yeah, thank you, sir. Well, we added the 2 hours that they used for traveling from Kampala to Boyogere, and then from Boyogere to Mukono, those are 3 hours. So you add the 2 hours plus the 3 hours, those are 5 hours. And then from Mukono to Kayunga, they used 1 hour. So when you add the 1 hour, it equates to 6 hours.
Okay, thank you. That is very correct. So that's how we got the 6 hours. So our time is 6 hours. Now what next? So in order for us to get this average speed, we shall always have the total distance, which is 50 divided by 6. So the answer you get will be your average speed. So our average speed will be roughly 8.3. So whenever they ask you, what is average speed? Average speed is that total distance that you cover divided by the total time you take to cover that particular distance. So this is our topic. And let me hope we are on the same page. Kindly type in the chat whether we are on the same page or there is anyone we are leaving behind. In case we are on the same page, type in the chat that we are there. Type in the chat and tell us that yes, we are there on the same page and we are good to continue. Okay. Looking in the chat, people are saying yeah, yes. Okay. Now we can go on and write something. Yes. Oh, someone wanted the definition. The definition of average speed is the ratio of the total distance covered to the total time taken. That's how you can define it. That average speed is the ratio of the total distance covered to the total time taken. So I'm asking you now to write that formula. Okay, when you finish, kindly you tell us in the chat that I have finished. I have finished. Okay, done. Okay. Okay, I feel it was really okay. Okay, good. Yeah. So, but let me ask, I'm seeing some people. I want to ask Sarah, have you finished? Right?
Yes, teacher.
Okay. I ask one boy, which boy? Let me see, which person? Meeting. Keith, have you finished? Kevin, have you finished? Okay. Okay, good. There's an activity. This activity is for you to try out. And I'm spotting out because I have seen in this group we have Angel. So if I tell you are Angel, get ready to do for us the number. So I want us to first try out on our own. Try out on your own. First give it a try. Find out what is the total distance that Angel is covering and what is the total time, and then go on and get the average speed. So let us first try. Yes. As I spot out whether we have some angels here. Angels don't hide. Angel and Shona. Kind of unmute.
Teacher, we're still working it out.
We're still working it out.
Okay. Don't mute. You are the one who are going to work it out. When you get finished, you let us know. So those who are finished, feel free to share with us what you are getting in the chat. As we wait for Angel and Shona. Angel, we set. Okay. Angel and Shona, can you unmute? And you take.
So, teacher, we got the distance. We added the distance.
Yeah.
That's 26 plus 42.
Okay.
Then we
What did
added
you get for total distance?
68.
Okay.
Then we added the total time. That's 3 plus 2. Okay. That's 5. Then we got 68 divided by 5.
Yeah.
And we got 13.6
13.6.
kilometers per hour.
Okay. Thank you. Thank you. Yes. Hope everyone, those are the answers you have. Yes. Hope those are the answers you have. Okay. I feel okay. Yeah. Okay, good. Hope we're on the same page. We can now continue. Those who have not got the answer, that's how we go. Thank you, Angel and Shona. So we can go on. And in case you find your name, still also you get ready to do for us in case it is your name that appears in the questions. Yes. Now for this one, I want you to first write your question. You have to first read it carefully. There is something that is hidden. Let me, by show of hand, can someone tell us which information are they hiding from us? There is something hidden. Davinia.
Okay, teacher, first of all, they have not given us the distance, but rather we have the speed and the time. So we have to first get the distance.
Wow, perfect. Thank you. Thank you, Davinia. Yes, that distance. Emily is saying that distance. Frith is saying that distance. No, Tasha, I'm not forgetting you. Oh, also, I'm not everyone. Okay, now I'm going to get the first person. Okay, the distance. Who wants to calculate for us the distance for the first tryout? First tryout, we are going to have 4 people. One will be able to tell us the distance for the first. Then we have the second one to tell us the distance is getting. Yeah, like that, like that. We can have the first person, but I'm going to choose those who have not said anything first. I know Davinia has said something. Angel, okay, Patricia has not said anything. Elvis also unmute. And Patricia be the first to tell us.
Okay. In the first 3 hours of the journey, the bus traveled at a speed of 20 kilometers per hour. So distance is equals to speed times time.
Okay.
Speed is 20 kilometers per hour times the time, that is 3 hours, which will give us 60 kilometers.
Okay, thank you. And that is Patricia. Okay, that was our first distance. Thank you. Then Elvis. Am I failing on Elvis? Elvis?
Yes. Yes, thank you, sir. The distance in the second situation is that distance is equal to speed times time. They have given us the speed, which is 25 kilometers per hour. So it is 25 times 2 hours. All the hours will go and we shall measure the distance, which is 50 kilometers.
Okay, thank you, Elvis. We can have another person tell us the total distance for the journey. Sarah, do you want to tell us the total distance for the journey?
Yes, teacher.
Okay. So what is the total distance?
110 kilometers.
110. How have you gotten that?
By adding the first journey and the second journey.
Okay, so 60 plus 50. What's your answer?
110 kilometers.
110 kilometers. Okay, good. I can have another one. Hope for Nix. 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 Unmute. Oh,
110 kilometers.
okay. And Nix, can you take us to the next one, to the next part? Of getting what is your total time?
Total time is 5 hours.
Is 5. Okay. Okay, good. 5 hours. And then Naluvega, unmute. Miriam Grace.
Yes, please, sir.
Okay, complete for us the number.
Okay, the average speed equals total distance out of total time.
Okay.
Distance is
What is the total distance?
the total distance is 110 kilometers. And then the total time is 5 hours.
Okay. So, sorry?
When we divide, we shall get 22 kilometers per hour.
Okay, so when you divide, you get 22 kilometers per hour. Okay, thank you, Miriam. Thank you. And let me hope everyone has understood. Yes, hope everyone has understood that and we can continue. Next, do you have a question? Next, do you have a question? I think next is okay. It is okay. Okay, thank you, everyone. That was our answer, 22 kilometers per hour. Okay. I think we are good to continue, but in case you get some challenges, you let me know. Good. Now, what are the key things you need to note? One is that when it comes to average speed is a scalar quantity. So a scalar quantity, like for it, we do not mind about the direction something moves. Oh, let me first mute. Okay, so when we talk about average speed, we are not looking at the direction. We only look at the size. And I want to let you know, when they talk about size in, oh, let me check. Okay. Okay. When they talk about size, when they talk about magnitude, for you, in order for you to understand it, consider it like how long, how big. Now, in case I'm talking about speed, I'll talk about how big is it? How fast are you? That is the speed. That's what we call the size. How fast is someone? But we don't look at where did the person go? Where did the speed take the person? No, we don't look at that. We just look at how fast was he that the person was really very fast. Those who have seen the president's convoy, you can testify that they are really very fast when they are driving and they are very skilled. So that one, we say that for average speed for the president vehicle, you may find them driving at 70 kilometers because they are really very fast. So that is what we call as magnitude, the size. Okay. So that one, you need to take note of it, what you call average speed. So here, the key point I want you to take note is that average speed is a scalar quantity. So when they ask for examples of scalar quantities, bring out the speed. Okay. Are we good to continue? Samsung, yes, Samsung.
I'm asking,
Oh,
like,
yes.
when they ask you that the examples of scalar quantities, do you give average speed or speed only, like that?
Yes, now once you mention speed, there is no need for you to mention average speed. But in case you use average speed, then don't repeat speed because they are almost the same.
Okay,
So you
thank
mention one of them. Yes.
Thank you.
Okay. Okay, I think we are good to continue. Can continue and look at another concept. Okay. Okay. Now we are taking off into physics. So we can take off onto another word. Another word now we are going to meet after looking at speed. Speed is related to velocity. Now that's what I'm bringing. That speed, we are looking at how fast someone moves. But when I'm talking about velocity, I'm going to talk about two things. How fast someone moves and in which direction does he go in. That's what you call the velocity. So when you look at the two vehicles we have on the screen, we have the speed and we have the velocity. So when I'm talking about speed, I'm emphasizing how fast someone travels. When I'm talking about velocity, here I'm going to look at the direction someone is moving and how fast someone is. That is the difference. That speed, you look at how fast someone moves. Velocity, also look at the direction. Was it now in physics or when we are talking in science, directions, you can look at the up. Is the person going up? Is he going down? Is he going to the left? Is he going to the right? Is he going in the northeast, southeast? Which direction was he taking? That we saw someone taking off, but where was he taking off? Which direction did he take? So when you talk about the speed that we saw, Museveni's vehicle was taking off at 75 kilometers per hour in the east direction, then that one is velocity. The moment you don't mention the direction, then that one ceases to be called velocity and we shall be calling it speed. I'm going to put here a statement and I want people to tell me let me put, I will say Tasha moved at 20 kilometers per hour in the eastern direction. Then I'm going to put another one. I'm going to put, let me put a boy. That's a boy. Daniel moved at 10 kilometers per hour. I want you to tell me in the chat which statement, which person has speed and which person is describing velocity. When you look at those two statements, say, Tasha, okay, people, okay, okay, let me choose today, Desley. Desley?
Is representing the direction. Then Daniel representing speed.
Okay, very good, very good. Okay, Faith, let's move. That's what you are going to tell us, Faith?
Yes.
Okay, what were you going to say?
Yeah, I was going to say that for Tasha, it is velocity because they've given that direction. And then for Daniel, it is speed.
Okay, very good. So now this 20 kilometers is what you call the magnitude. Eastern is what you call the direction. Then I want you to tell me, I'm putting two words. Of the two, which one, who is having a vector, which one represents a vector quantity and which one represents a scalar quantity? Yes, of those two people, who is representing a vector quantity and who is representing a scalar? Tima?
Tasha is representing a vector quantity while Daniel is representing a scalar quantity.
You tell us why.
Because Tasha moved at 20 meters per hour in action.
Okay.
Then
okay.
Daniel has magnitude
Okay.
and no direction.
Okay, good. Okay, that is very good. That is very, very good. Now we are going to continue. Don't write, we are going to write the next slide. Now, what do I want you to tell you? One, you are going to distinguish the two. When we are talking about speed, let me ask in the chat. I have two words I'm going to write. Distance. Oh, no, let me write here. And I see how people are going to, I'm going to ask you to match them. To match, you are going to write on my screen, don't worry. I want those who can write to match these words. Either you take an arrow that this one is going here, this one is related to this. This down one is related to velocity, the up one is related to speed. So I want you to let me enable, and I have people write. Feel free to write on my screen, and then you put an arrow. Which word matches well with the other? You can write on my screen. Those who see, that is Tasha. Okay. I'm saying Nalubega. Okay. Okay. Now, even those people who are unable to write, use the chat to type for us that speed is related to displacement. This one is related to this. And we see also those who are unable to write. Looking in the chat. Looking in the chat. Okay. Okay. Angel and Shona, they are saying speed is related to distance, velocity is related to displacement. Speed, distance, direction, displacement. Well, wow, good. Distance, velocity. Okay. Now allow me to disable you to write, and I clean the board, such that we can have a clean board. Okay, good. Thank you so much for trying. But now we need to have seen correct answers in the chat, but please, we need to take notes. Someone has something. Davinia, what do you have to say? Yes?
Okay, wanted to say with velocity, speed in a given direction, whereas the distance will go with the speed.
Okay, very good. So she's telling us that when we are talking about displacement, we look at the direction. When we are talking about distance, we don't look at no direction being considered. And therefore, distance will always go with speed and displacement will always go with velocity. Now in the chat, can everyone write for us what is the formula for finding speed? How do we find speed in the chat? Let us see those who went through the work. Speed, how do we get speed? What is the formula for speed? Speed. Someone is saying us speed is distance times time. Distance divided by time. Distance over time. So here, since we said we use the word distance, that's why we say speed is distance over time. Now let me check out, what about velocity? We have said speed, we use distance out of time. What do you think we shall use for velocity? Can someone write in the chat the formula for velocity? Now we're on velocity. I want to see the formula for velocity, for finding velocity. That is good, Zanita. Anila, that is good. Itel has something. Itel. Okay. Yes. I want you to write the formula. Okay, Sarah, that is okay. Yes. So I think people have started discovering the formula for finding velocity. Very good. Now, whenever you talk about velocity, Mega told us is also called angel. Yes, we always use displacement out of time. By show of hand, can someone raise up the hand and you tell us, how do we define velocity? I want you using that. Okay, Gladish was the first.
Velocity is the rate of change of displacement with time.
Perfect. Thank you. That is good. Patricia.
Velocity is a quantity that designates how fast and in what direction a point is moving.
Wow, perfect. Freeze.
Okay. Velocity is rate of change of distance moved with time in a specific direction.
Wow, good. Nairobi. Hope people are writing the definitions. Nairobi.
Velocity is the speed of an object in a given direction.
Okay, good. Mega Agatha Daniel.
Velocity is the speed in combination with the direction of motion of an object.
Okay, good. I think we have exhausted all. That is very good. Yes. So in case you forget any definition, or you always come back to the formula. Know that velocity is displacement over time. So you can say is the ratio of displacement to time. Or you can say is the rate of change of displacement with time. At times even you can ignore the word with time because rate always relates with time. Okay. We can now continue. So hope people have got the definition. So whenever we shall be talking about velocity, we shall be talking. So let me give you the summary. Let us write that summary. Okay. Allow me to animate or to mute people. So let's summarize. So like I've told you, whenever they talk about velocity, the word displacement is key in your definition when you are defining. And in some books, to depend on which kind of book you read, so you'll find some even saying velocity, this is the rate of change of displacement. Why? Because always when we mention rate, in most cases, we are referring with time. So rate always means time. Or in mathematically, when you see a rate, we are looking at a ratio. We are looking at a ratio. Yes. So I saw people putting that displacement is capital D. Please, from today onwards, what you need to know is that displacement doesn't have a specific letter. But when we go in front, after maybe today's lesson, we shall come to learn that displacement, we can use the letter S, is the common letter. S is the common letter to represent displacement. But we shall look at it later. Okay, so let us summarize those key points. When you finish, you let us know. Oh, what is displacement? What? Now, when we talk about displacement, displacement is the distance moved in a given direction. I think, Desley, do you have something as people are summarizing and joining?
It was almost close like your definition.
Okay.
But mine is that this displacement moves according to the direction.
Okay. Okay. Good.
And with displacement, it changes the position.
Okay. Perfect. Perfect. Joy.
So mine is the same definition as yours.
Okay, you tell us also, don't worry.
Displacement is the distance moved in a specific direction.
Is it possible to give us an example?
Yeah.
Okay, go on. A quick one we can give you is, hope you have those people who enjoy motor rallies. Those people are always following a given direction. Melinda, so they're always following. You can unmute Melinda. They're always following. So always that one, we call it displacement for them. Yes, Melinda? Okay. Hope people have finished this.
With me, displacement is the distance moved in a given direction.
Okay, good. Good.
Yeah.
Okay. Okay, people have finished. Okay, we can continue. Prime, do you have something?
So I wanted to give an example.
Okay, give.
When someone is shooting a bullet, they target at a certain point and then they shoot. So the bullet moves in that particular direction.
Wow, wow, wow. Very good. That is very correct. Thank you. Yes, and that one, later on, we shall also look at what you call, okay, recoil velocity, but that is very correct. A bullet, you target at something, and always to move in that particular direction. Thank you, Frank. Now, we are going to look at two things. I want you to look at these two things on the board. Critically, use your inner eye, that deep eye. These pictures are demonstrating two things. And I want someone who is going to tell us, people who are going to tell us what is the difference between uniform motion and non-uniform motion. What are you observing? Yeah, look at them very well. Ask yourself, those pictures must be able to make you understand what we call uniform motion, what we call non-uniform motion. So I want you to look at them, see what is... I want someone who has not yet... Yes, let me start with Becky.
In uniform motion, the distance is constant, while in non-uniform motion, it has no specific range.
Okay, very good. That is one of the difference, members. Check out. Thank you. I'm first checking people who have not said anything. Samsung. Oh, Samsung, come on.
Teacher, the uniform motion is constant and then non-uniform motion varies. That's what I think.
Okay, what is that thing that is constant?
The uniform motion and then the non, I think for it varies.
Yes, now mention for us, tell us what is that thing that is constant?
As in...
Yes? Okay, thank you. Yes. Yes, something is constant and something varies. Okay, good. Will Faith?
Yeah, so mine is also related to theirs. I want to say that in uniform motion, the distance is constant, and then in non-uniform, it just varies.
Okay, good. Thank you. Then lastly, CJ. CJ. Okay. Okay. Okay, Tasha. Okay. Okay.
Yes, sir.
Yes, tell us what you may have.
And uniform motion involves covering equal distances in equal intervals of time, whereas non-uniform motion involves covering unequal distances in equal intervals of time. Yes?
Okay, good. So those are some of the differences that you have to take note of. When you look at uniform motion, the time intervals. This is 1 hour, 1 hour. But in every 1 hour, this vehicle is covering 10 kilometers. So in uniform motion, the distance is the same that this particular vehicle covers in a particular given interval of time. But when you look at non-uniform motion, in non-uniform motion, the distance is different for almost every time, because you notice it keeps on changing. And now this is where I'm going to ask you. When you look at on these two motions, you are going to type in the chat. When we are moving from Kampala to Kayunga, which kind of motion were we having? What type of motion on those two? And you must have a reason. Oh, raise up the hand. Desley? Desley, I'm failing. Yes, Desley?
Can you first repeat that question?
I'm asking, when we are moving from Kayunga, from our initial example scenario, we are moving from Kampala to Kayunga. Which kind of motion was that?
It was non-uniform motion.
Why?
Because first of all, the distance was dropping as it gets high, so it was not as a uniform motion because it kept on changing its distance.
Okay, okay. Thank you, thank you. Hope now everyone notices that because we said this person was moving from Kampala to Weyogirere, the distance was little, but it took about 3 hours. So the distance was, the hours were moving, different hours, different time intervals. Good. So can you write in your books what you call okay. Hope everyone has written something about uniform motion and non-uniform motion. So make sure you make your small notes depending on what you have understood. Is that okay? Even the graphs, you can even use the graphs that when it comes to uniform motion, a straight line graph is obtained. Under non-uniform motion, a nonlinear graph, we call it a nonlinear graph, is obtained. So can you write, let me give you some 2 minutes, everyone to first summarize the difference between uniform motion and non-uniform motion. So summarize. Okay. Okay, good. I think people, okay. Okay, now people who are using the chat. Okay, good. Okay, we can now continue and look at what we call uniform velocity. Now, when we talk about uniform velocity, means the rate at which the displacement is the constant rate. So whenever you hear the word uniform, this word is a must to appear. What we call equal constant. So uniform means that the rate at which the displacement changes with time is the same. Now, for example, this one is what we are calling uniform motion. When it comes to uniform velocity, it is an example of uniform motion. That for anything that is moving, let me say this is your start, this is the next hour, this is, let me say this is 1, this is 2, this is 3. So for every hour that is passing, let me say, because here is covering 2 kilometers, also here will cover 2 kilometers, will cover 2 kilometers. So that displacement is taking in a big given direction. It is the same throughout the whole journey. So that's why we use the word constant. So the constant, the distance covered in every hour in a given direction is the same. That even when it changes the direction and it looks there, you will all as well cover the same distance. Okay, summarize. Tekino, you have a question? Tekino and Mirembe Janice, unmute.
Master.
Yes.
Is uniform velocity the same as uniform motion?
Oh, no. Now, when we talk about uniform motion, it is general. It is a general thing. Yes, so it can have displacement, it can be distance, it can be anything with dealing with motion. It can be time. But when we go to uniform velocity, then here we are specific, we are looking at the speed something is moving with. Time is going to come when we are going to look at uniform acceleration, uniform displacement. Okay. So uniform motion is general. It has distance, it has time, it has speed, it has velocity, it has acceleration, it has everything. Okay. Type in the chat those who have finished to write, such that we know whether we can move on. Okay. Okay, some. Okay, I think many. Okay, I think many have finished. Okay, I think many have finished, and now we can go on and dive. Okay, so let us dive. Now, you first draw that table. We are drawing this table in your books, and we are going to plot, and we check how our uniform velocity graph looks like. So I'm going to ask you to plot. You may not be very accurate, as long as you can be able to demonstrate. Now, always, dear friends, when it comes to graphing, time always will appear on the x-axis in seconds. Displacement, any other quantity that you are dealing with, always appears on the vertical. So why? Time is an independent variable. Displacement is a dependent. So always we shall have our displacement against time. So I'm going to just have 0, 1, 2, 3, and 4. Then displacement I can have 1, I can have 2, 3, 4, 5, and 6. What are you noticing? I start plotting 0 and 0. So everyone is going to plot those points. 0, 0, it's going to be here. This is 1, 2. Remember, we are plotting 1, 2. We are plotting 2, 4. We are plotting 3, 6. We are plotting 0, 0. Why? Time is on the x-axis and displacement is on the y-axis. So whenever we are plotting, we always start with x and then y. So I have 1, 2 is here. I have 2, 4 is here. And then last I have 3, 6 somewhere here. So join your points using a straight line. Don't use a hand, because for me I don't have a ruler. Use a ruler to draw a good straight line. And I want to let you know, whenever it comes to uniform, it will look like that. So that's how it looks like. Make sure you do something accurate. So Gladys, Teta, let us come back to class. Let's come back to class. So we are plotting that. Let me allow you to unmute and you tell us whether you are done. Yes, Milembe.
Sir,
Yes.
I need help me with the reason as to why the time is on the x-axis. I didn't note it down.
The time on the x-axis, huh?
Like, why is it put on the time on the what on the x-axis? You gave the reason, but I didn't note it down.
Oh, okay.
Yes.
Now, for displacement to occur, for you to be able to move, we always look at the time. So time is very important. I don't want to say compared to displacement, but for you, in order for you to know whether you have moved, whether you have progressed, you always depend on the time. So displacement is depending on the time. Are you getting it?
Sir,
Yes.
no. Like, you have
mm,
said for displacement to
yes.
occur, it depends on, you have said for displacement to occur, it depends on
Yes.
that time.
Yes. Take an example. For you to know whether you have gone for a given journey, whether you have progressed, what you look at the time you have taken to determine how long the journey is. So for you to determine that this journey is far, you always depend on the time. You don't look at, it is rare. It's like you don't look at you always look at the time you have taken. So to say that Kenya is far, you look at the time the journey takes. Is
Oh,
that
okay.
So that's
Yes,
why
thank
time
you,
is
sir.
on the, yes. So that's why when you hear people say, this side is far, they always look at the time you take. Otherwise, that distance is very small. When I'm using a plane to go to Kapchora, it takes me about 20 minutes. So I can say it is near. But when you're using a vehicle, it will take you 3 hours, 4 hours. So you'll say it is far, depending on the time.
Yeah.
Yes.
How about, what if you depend on the speed? Like the speed of the, on the speed like of the vehicle in which you're using to.
Now, yes. Now that one, we shall also have those graphs, eh? Yes. So we shall have speed time graphs. We shall have distance time graphs like that.
Okay.
So it depends on which quantity are we plotting. In case it is speed and time, that one also speed will look at the time. So speed will depend on time. When I'm looking at speed and displacement, I'll look at speed as my dependent variable. That for you to determine how fast something is or how fast you have reached a place, it depends on the speed you have used. So that one is displacement and speed.
Okay, sir.
Okay. Okay. So let me hope everyone has drawn something very accurate. So now we are going to calculate. That's why I wanted you to have something accurate. We are going to go to the calculations of obtaining velocity. Okay. So hope now I'm going to display my accurate graph. Here, this was rough. That is my accurate graph. And for this graph, I may ask you to find the velocity. So how do we find a velocity for this kind of graph? So we know that velocity is given by displacement out of time. So what do? I'm going to find one velocity, and for you, find for me the rest of the velocities. Take an example. I want to find the velocity V1. So to find V1, I'm going to come. V1 starts from where? Remember, for you to achieve velocity, it means you have moved, which is displacement. So displacement is along the vertical axis and time is along the horizontal. Now I'm going to ask myself, I'm moving from this point up to this point. What is the displacement? What distance have I moved? So when someone moves from zero, from this point A to point B, through the chart, can we quickly type in what distance has that person moved? What displacement? Type in the chat. I want to see now those paying attention. When someone moves from A to B, what displacement? Perfect, perfect, perfect. Yes. Yes, 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 yes. So it is 2. Yes, very good. The person has moved 2 meters. Very good. So the 2 meters, you look at the vertical. You look at the vertical. That from here up to here is 2 meters. Very good. So I will say displacement is 2. Divide by, what about the time? From here up to here, is everyone noticing that this is 1? So I will say out of 1. Therefore, V1 is equal to 2 meters per second. Your task now is to find for me, what about when someone moves from A, now this is, let me say, from B, this is B, to C. Someone has started from B and is moving to C. Find the velocity, that is V2. Still, someone is moving from B to C. What velocity has what is the velocity this person is using? Still get the displacement I want. Hey, people have found it. Shannon. Oh. Yes. Yes, okay. Elvis, you want to say something? Oh. Yes, Elvis.
Yes, it is 2 meters. We shall
Okay.
change it. Yes.
Okay, tell us. Continue.
Like this time around, you're just going to move from B to C. So our, like on displacement side, this time around our 0 will be at 2.
Okay.
And when we are considering time, this time around we shall look the line down there. It will start from the 1 will now become our 0.
Okay.
The 1 will become our 0, then the 2 will become 1. So the time will be 1. It will be 2 out of 1.
2 out of 1, which is still 2. So those who are not seeing it very well, here you have 4. Down here you have 2. So in between 4 and 2, the distance you have is 2. You can just say 4 minus 2. Then down here you have from 1 to 2. So the distance will be 2 minus 1, which is 1. So you get your velocity as 2 meters per second. So even when you calculate V3, you will still get 2 meters per second. And therefore, you can conclude and say that this body is moving uniformly because the displacement and the time is the same. And therefore, this is what we call uniform velocity. For whatever part of the journey you check out this person, you will find that this person has moved at the same velocity. Any questions? Oh, okay. I think, okay. Let me first. Okay. Yeah. Okay. Someone has a question. Unmute.
Okay, teacher.
Yes.
Okay, my question is our V2 from B to C or?
Oh, I beg your pardon. You are not loud. You're saying?
I'm asking why didn't we start from 0 to?
Why?
Why didn't we start from 0, which is point A, in our B velocity 2?
Oh, in velocity. No, now here we wanted to obtain. What if we are considering the journey from B here to C? So we wanted to test that if something is uniform, is it that for whatever particular point you choose, you get the same answer?
Oh, okay.
That's what we are looking at. Okay. Okay, I've crossed the chart. Okay, so hope this is okay. This is okay. Okay, so even V3, you'd have obtained the same answer. So for whatever point you test, you'll get the same answer. Even if you test here and here, you still get the same thing. So that one shows you it is uniform velocity. But for anything that is not uniform, you would have found out that you are getting something very different. For whatever point you test, you will notice you're getting something very different. Okay. Okay. Now, for that one, yes. For a body whose displacement is not constant in any given time, is said to have what you call non-uniform velocity. So for non-uniform velocity, that is where you have a body moving, but its displacement is not constant throughout. You find him at 20 kilometers, he's just covered something. When the time is different, everything is totally different. That is the first example we had of non-uniform velocity of someone moving from Kayunga to Kampala. Yes. And for non-uniform velocity, even you may find yourself getting a what? Okay, okay, okay. So non-uniform velocity, at times you find your graphs in zigzag format because displacement is not constant. So for it, you can find it not constant. I hope we have finished to write that statement. Let me hope. Has everyone finished? Has everyone finished? You can type yes or no. I wanted you. Okay, I think we can. Okay, good. Okay, you can also write that, the differences.
Progress. For example, the right, that is why C that what be for a set that can interact outside that point. So they are telling us that this weight cell all the things have to be same as that.
I think people are there. Focus. Done. Let me allow Unmute and say whether you have finished or not.
Yes.
No, not
Yes.
we are done. We are done.
We can continue.
So we are Daniel.
You can continue.
Okay.
We've not yet. Not yet. Not yet.
We have heard.
I think people have finished. Okay, now we are starting real physics here. Pay attention. Yeah, we are going to talk about a lot of terms, so you need to be very careful. That's right, and then I'm going to talk. Okay. Now let me start the talking. Now, when we talk in physics or in science, we have different types of velocities. Whenever, when you are starting to move or when you are in motion, always you have a given, I'm going to use the word speed. You always have a given speed you are moving with. However, initial means the time when they start the timing. You can be in motion, but when you have not started the timer, So the time you start timing is what we call the initial velocity. So that velocity can be, it can be, when, like, let me say, when you are setting off from home and you are coming to Kampala or you are coming to town, the speed you start with is what we call the initial velocity. But that velocity always depends on the time you have started timing. Someone may start timing. Take an example. I can have 8. This is 9. This is at 10. This is 11. You may be moving the whole day, but when you have not started timing. So that time when you start timing, that velocity you are having is what you call the initial velocity. So when you start your clock at 9, yet you started moving at 8, this time you have started is what we call, the velocity you have is what we shall be calling the initial velocity. When you start at 0, then that is the initial velocity. Please do not cram. I noticed it in senior 4 and senior 6 when people are telling me that initial velocity is always 0. No, it's not always 0. Initial velocity means that time you start timing for you to start your motion. So it can be even a 5, it can be a 6. We have seen people who start driving at 5 meters per second. We have seen people who start timing when they are driving at 50 kilometers per hour. So timing is very important in terms of when we are talking about the velocities. So how do we represent initial velocity? Initial velocity is represented by u. So whenever you find that small u, it represents initial velocity. That velocity you start with. Then whenever you see the word that someone was starting from rest, when someone is starting from rest, initially is just starting, then that one, we shall assume that u is always 0. That means, remember, when you are starting the journey, you don't have any speed you are starting with. You are starting fresh, very fresh. So there is no speed. You have not moved. And whenever you have not moved, you cannot have any speed being covered. Therefore, initial, when you see the word starting from rest, then it means that your u is equal to 0. Or whenever they use the word stationary body, a stationary body is that body that is not moving. Stationary means you are static. You are in one place. You are not moving anywhere. Take an example. Right now, many of you are seated. So we shall say you are static. You are not moving. So any body that is not moving, it means that its velocity, u, is equal to 0. Kindly let me know in the chat whether that thing has sunk into your heads, that now it is okay. Is velocity the same as time? No, they are not. Yes. Okay. So velocity and time are different things. Velocity is like speed. Velocity means speed you are moving with, but here you consider the direction you are taking. Then time is like hours, how long you take to cover something. Then velocity is the speed, how fast you move to get somewhere. So initial means starting the motion, starting to move. Whenever you start to move, that's what you call the initial velocity, the initial speed you start with to move. So we have started, u means initial velocity. So when you find u, will mean initial velocity. Okay. I think I'm going to move to the second screen. I'm going to move to the second screen. I'm going to move to the next screen and I explain the next term. Now, the next term we are having, Desley, I saw your hand up. Okay. I think it is okay. I want to move to the second screen. So when you are moving from home, those people who know how to ride bicycles, when you are, let me explain this using a bicycle. This is this is the person on a bicycle. This is our bicycle. And this person is coming down here down. Now, when it's starting to move to come down, the velocity he has at this point is what you call the initial velocity. This is what you call the initial velocity. The velocity is going to have down here when he reaches here is what you call final velocity. So initial velocity is the one that you are starting with when you are coming down. The velocity you finish with is what you call the final velocity. So initial velocity is what you start with as you are moving. Final velocity is what you end with. That speed that you have when you are coming to rest, when you are stopping, is what you call final velocity. So initial is when you are starting. Final is when you have come to the conclusion of your journey. Hope is now very okay. So final, we use V. Initial, we use U. Okay, let me pick a hand. Milembe.
Sir, does velocity have like a specific definition?
Yes.
What is the
Velocity, you can define it as the ratio of displacement or the distance you move in a specified direction against time. Or displacement out of time. This is velocity. Yes, but velocity literally means the speed you are moving with, taking into consideration the direction.
Okay, sir.
So velocity is like speed, but here you look at the direction you are taking, whether you are moving up, down, east, west, that is what is important, but it is speed. Desiree, how fast you move in a given direction is what you call velocity. Yes, Desiree? Okay. Desiree, you can ask.
Before you starting your interest is
Okay, Desiree, I've not picked. I've not picked. Now someone, yes? Desiree, kindly type. I'm not hearing. Kindly type. Someone is asking in the chat, is this related to light because of U and V? No. U in light stands for object distance. V stands for final distance. So U and V in light is totally different from this side. So here U stands for initial velocity, V stands for the final velocity. Okay. So let us write. So these ones are going to be very crucial. When you are starting to move, that is uniform velocity. When you are coming to the rest, yes, I think those people who know it very well. In case you play a lot at home, you have your bicycle, you have your car. When you are starting, you'll move very fast. But when you are coming to the end, you hold the brakes. So the moment you hold the brakes like this, it means that you are going to stop moving. So your speed is going to reduce. So once your speed reduces, we shall say that now this person is finally coming to rest. So finally coming to rest. And once you come to rest, it means you are not moving. So I want you to remember that velocity always is displacement out of time. So if you have not yet started moving, it means that the displacement, the distance is 0. So that's why I was telling you, for initial velocity, U is equal to 0. The moment they tell you someone is starting from rest, someone has been stationary, it means that person has not moved anything. So U is 0. Then when someone comes to rest, like when you are finishing your heel, you are coming down at this point down, you are going to hold the brakes. And the moment you hold your brakes, you are going to come to rest. So you'll see your, in case you are driving, those people who know how to drive, let me say here there is a kilometer per hour. When you are coming to rest, when you hold the brakes, you will start seeing this timer coming down. Ta, ta, ta. It will move, ta, 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 ta. Then it comes down. Now, this is what we call the final velocity, that now you are coming to rest. When you increase your speed, it goes back and it moves. So now that velocity you are moving with, we call it the initial velocity or the velocity you are traveling with. When you reduce the speed, you step on the brake, then it will turn back. Okay. Have you finished to write that? Now someone is saying, yes. Now when it comes to initial velocity, time starts is 0 because that's when you start timing. Now so what it means final velocity is always 0? No. It is always 0 when you have come to rest. Yes. Someone may just stop timing you. So where the person stops timing you, we shall say that that is the velocity you have ended with. But it's not always 0. It is always 0 when you have come to rest. But once the question doesn't specify that you have come to rest, then never take it to be 0. It only comes to 0 when they have told you this person has come to rest. Mirembe?
Sir, what about the distance in between before someone like starts and before they rest?
Now that one, yes, that one we are going to be calculating it. That distance, we shall be calculating it. Okay. And that is the one you use in order for you to get the velocities at times. Okay. So like we are talking about what we call average speed. So here when it comes to average is like you add what you have, divide by 2. Take an example. When someone scores an 80 in math in one of the papers and he scores a 90 in another paper, the average is going to be 80 plus 90 divided by 2. 80, this is, let me say you do your mid-term, you get 80, end of term, you get 90. So the average mark you're going to get will be 80 plus 90 divided by 2, which will give you around 85. So your average mark is 85. So still when it comes to average velocity, in order for us to obtain that velocity, we always get the mid-term or the BOT. BOT is the mark you start with. In fact, let me explain initial velocity using this. So your initial velocity is the mark you get at the start of the term. What you finish with at the end of the term is what we call final velocity. The first mark you get when you go back to school in your both beginning of term exams or mid-term, we can call it initial velocity. What you get at the end of the term is what we call the final velocity or the final mark. So to get the average, get what you started with in both in the beginning of term plus what you got at the end, divide by 2. That's what we call average velocity. Let me hope now that term is very okay. Then there is this crucial word. Oh, very important. Very important. We call acceleration. What is accelerating? Accelerating means the way velocity changes with time is the change in the velocity over a given period of time. Whenever you are moving, at times you find yourself changing. So that kind of changing is what we call acceleration. So first write, and then we are going to dig deep into that. Yes. And please, okay, summarize. When you finish, you let me know. Oh. Do we measure velocity? Yes, velocity can be measured. Velocity can be measured. Yes, when we shall be looking at what we call the ticker timers, we shall look at how we measure velocity. Okay, yes, yes. So please make sure you always study hard. Yes, Vanessa, that assumption is very okay. But Vanessa, it's not always that V will be higher than U. For acceleration, it can be okay. But when it comes to deceleration, it can be different. But one value will always be higher than the other. Okay, done. Now, let me explain this again. Now, how do we represent acceleration? Acceleration, we use a small a letter. So small letter like A will equal to final velocity, which is V, initial velocity, which is U, divided by T. Now this formula is very important, my dear students. You write it somewhere. Now you have started meeting some formulas. So acceleration is V minus U out of T. Next.
Sir.
Yeah.
If that ask a question,
yeah,
do they give you the do they give you like that? They give you the final velocity and they give you the units.
Yeah.
And the initial velocity.
Yes. Now we are going to learn how to interpret. So they will give you that velocity. Units for velocity are always meters per second for velocity. But when it comes to acceleration, now you look here. When it comes to acceleration, since we are looking at change in velocity, velocity is meters per second divided by time, which is second. Now, okay, you remember very well we said in math indices that 1 out of second is s power negative 1. So when you write this, you can write it as -1, -1, and -1 plus -1 gives you -2. So that's why we call it meters per second squared. Okay, lastly, Melinda.
So I already answered my question. I was also going to ask you about the same.
Have you heard me asking a question?
Yeah.
You have been asking.
Yeah.
So they give you the small new.
Okay, we can now continue. Now, this is the last activity we are going to be doing. Oh, you look at these beautiful pictures. What we call accelerating. That's what we call accelerating. Accelerating means like, you know, when you are starting to run, you keep on increasing your speed, you keep on increasing such that you can win. So you start slowly. I think when you accelerate, you start slowly, you go on increasing, increasing. So that's what you call accelerating. So your speed is changing every time. It keeps on going up, like that. But when you get tired, imagine after rotating five rounds around the pitch, you start cutting on your, when you have run 5 times around the pitch, you start cutting your speed. So when you start cutting the speed, we are going to say that person is decelerating. So decelerating means now you are cutting your speed. You have been running very fast and now you are coming down. So when someone starts slowing down, coming to rest, we shall say is decelerating. Yeah. So we shall talk about that. Okay, so these pictures, I wanted to show you what we call accelerating. Accelerating means keep on increasing the speed. Now, like you have reached senior 2. If at all in senior 1, you are putting in a little efforts. Senior 2, you increased. Senior 3, increase. Then senior 4, increase them more, such that by the time you get there, you are already on fire. Yes. Let us write this activity we are going to do together. Yes. And let more everyone knows that the best time to study is when you are very young. Things can enter the head very fast. But when you make up 20 years plus, my dear, you can struggle. Things start becoming hard. It becomes worse when you are 25. When grasping things is hard, at 30 it is worse. So your head will stop grasping things very well at around 26, 27. When you enter around 30, things become a bit hard for you to grasp. So you start grasping a little. So when now your brains are still very young, you need to work hard such that you grasp a lot of things, such that by the time you reach that age, at least you have a lot you have grasped it. So we are going to do this activity. Yes. But please always never lose hope. Anything can. If you have a dream, you have to make sure you fulfill your dream. I have a friend is in one of the schools. She's a lady. She's about 30 years, 40 years, in fact, 45, I think. But she went back to study senior 4. She sat senior 4, and now last year she was in senior 5, and now she's in senior 6. So if there's anything, please, academics are so important. She dropped out thinking things are not so serious, that she may not need them. But now she has realized that with academics, you can go far, but you will reach a point where you'd feel you need the books a lot. So kindly, let's utilize our time profitably. Now we have this simple activity on the board. Now, in order for you to pass these questions well, always first go through the question, interpret, and summarize. So they are telling us that a car starts from rest. Like I told you, starting from rest, it means this person has not covered any distance. And whenever they tell you that something is starting from rest, it means no distance has been covered. So for this case, it means that our initial velocity, let me check those who have been following. Our initial velocity, which we are calling u, what is going to be the answer? Type in the chat. I want to see those people who have been following. Okay, very good, very good, very good. So our initial velocity here we shall say is 0 meters per second, because this person is starting from rest. Then they told us, and acquires a final velocity. So I'll say final velocity V is equal to 60 meters per second, and time, which we represent by t, is equal to 30 seconds. So you go back, find the acceleration of the car. So I'll say acceleration is v minus u out of t. My v is 60 minus u, which is 0, divided by time, which is 30. So I'll end up 60 minus 0 is 60, divided by 30, and I'll end up with 2 meters per second. That is our acceleration. Yeah. Type in the chat in case you have understood. Oh, yes, this is squared, sorry. This is squared because you are calculating. Yes, it is squared, it is squared. Yeah, thank you, Emily. Yeah, it is squared. Ian, yeah. Yeah, okay. Understood. Okay, so that's how you calculate. Okay, understood. Okay, Babidi, I've seen your question. Understood. Okay. Let me display another question. Should we first try this on our own, members?
Yes.
Okay.
Yeah, sure. Why not?
Okay.
Yes, sir.
Yes.
Okay.
Fine.
It's fine.
Yes, sir, we can try it.
Okay,
Let's
try it.
try it.
Okay, good.
Biology, chemistry.
I don't know that. Do we have any MAGA? I don't know if we have any MAGA, but we have
Yeah,
MEGA.
we have mega.
Okay, MEGA, prepare to take us through.
We have.
I can do the MAGA.
Yes, since MEGA and MAGA, you are close, MEGA will take us. I don't, because I've not seen any MAGA. MEGA, are you there? Rama Queen, are we on the same page? Okay, I'm seeing people. Okay. Okay, but how can you know when to put squared? One, to put squared is when you are dealing with acceleration. Acceleration, the units are squared. Yeah. So acceleration, the units are squared. Always. Okay. Where is mega? We have to mega or mega. One of those two can take us to. That. Mega, Agatha, Daniel, or Megan. Okay.
Okay. But I want to try it.
Okay, try. What is your U?
Okay, my u is 2 ms power negative 1.
Okay.
And then the final velocity is 9 ms power negative 1. And my time is 7 seconds.
Yeah.
So I say the acceleration is equals to the final velocity minus the initial velocity divided by the time, which is equals to 2 minus 2 divided by 7, which is equals to, yes?
Substitute value. What is your V?
My V is 9.
Minus U?
2.
Divide by?
7, which is the time.
Okay.
So 9 minus 2 is 7, divided by the time, which is 7. So I got my acceleration as 0 ms power negative 2.
There, mega. What is 7 divided by 7?
7 divided by 7, let me see. It's 1.
It's 1.
Okay, 1 ms power negative 2.
So this one, we read it as meters per second squared. Okay.
Okay, sir.
Okay. Hope we're on the same page. Of 1 meter. Milembe, unmute.
Sir, I have a question.
Yeah.
What if can they change the units of velocity from like meters per second, and then they like say kilometers, or it's always meters?
Okay, Milembe, keep on. Your answer is going to be here. Your answer is going to be answered on the next question. Your answer is going to be answered here. Oh, okay, Milembe, your answer is going to be answered here. It is very possible.
Okay. So do you first convert the
Yeah,
you first convert
exactly.
from then to meters?
Exactly.
Okay.
I want you to try this one. So here you need to be very careful on what is your U, what is your V. In the chat, can people summarize for us? I want to see whether people can tell us what is our U, what is... No, velocity, it says in some meters per second. So if you find that all units are in standard, there is no need for you to put them in there. Okay. Okay, U is 80, V is 60. Tasha. Check. Hey. You always need to read. Yes, Tasha, that is okay. U is 80, very good. Emily is saying, yeah, okay, good. So U is 80 meters per second, V is 60 meters per second, and time is 2 seconds. Hope the person who was asking, you have seen that U can be bigger than V. Okay, Gladish, unmute.
Just to do the question.
Okay, tell us.
Do
A
the
is equal
question.
to?
A is equal to V minus U over T. V is equal to 60 minus U is equals to 80 meters per second over time, which is 2 seconds.
Oh.
Now, when you subtract, when
Okay, so divide by 2. So this is negative 20.
it will be negative because deceleration.
Okay, very good. So you
Negative
get
square.
Okay, very good. So dear members, I have seen people who are writing 10. Members, it is not true. It's not true. It is negative 10. So negative 10, it shows you that you are coming to rest. It is a deceleration. So please and please take note of that. You are coming to rest. It is a deceleration. So take note of that. And like when you are been driving at a very high speed and you see a policeman in front of you, as a driver, you are going to step on the brakes. That's what we call decelerating. You have been driving at a very high speed and in front of you see a policeman, you are going to break off. So you'll decelerate. And even there is a feel, those who sit in the cars when they are driving you, when someone has been driving to a high speed and it comes, there is some kind of feel. You feel that there is some atmosphere now being felt. So that's what you call deceleration. So I want to stop sharing the screen. Yes, Mega?
Sir, do you represent deceleration also using A as compared to acceleration?
Yes. The only difference is that when there is a negative, it means deceleration. When it is positive, it means acceleration.
Okay, sir. Thank you.
Okay. Yeah. So kindly, I think I want to just give you some numbers you are going to try in your free time. I wanted to open the chat, but I don't want to risk. So let me display. You are going to try out these numbers in your free time. Just take a screenshot of that. So here, I'm going to test whether people know how to convert units. So first convert this to meters per second. Convert this to meters per second before you continue. Before you do anything, first convert those ones to, yes. And even in the questions, they're not going to be specifying that it is deceleration. No, they will always write acceleration. So for you, when you get a positive, no, that is the acceleration. You get a negative, that is deceleration. Like after deceleration means you are coming to rest. You have been driving at a very high speed. And fortunately, or unfortunately, you have noticed a policeman in front of you. So you want to panic to show him that you are reducing the speed. Okay. Yeah, but this one, the only thing you need to know is that in 1 kilometer has 1,000. In 1 kilometer, there are 1,000 meters. And in 1 hour, how many seconds do we have? About 3,600. So you need to convert that. But in case things not go on, yeah. So I'm going to send more 3 numbers in the chat, sorry, in the WhatsApp group for you to try out. So why don't you say, hey, yes, Milembe?
Yeah, like in the first question of Afema,
Hmm.
if they didn't tell us like if they don't give us like to represent it in meters per second, there's no need of converting.
Given that this time is in hours,
Yes.
So in case they are in kilometers per hour, also put the time in hours.
Okay.
Okay. Now time for asking just questions. Ask.
Okay, so at the beginning, you said that we were going to do some activity, but you've not done it.
No, I don't. Let me check. Someone was in my room. Oh, yeah, but I'm going to, I think I will send that link. Can you allow me to send it in your group, on the group?
Yeah.
Yeah, I will send it. But next time we shall start with that one.
So.
Okay. Yeah.
So.
Yes.
This number, the first one. If I'm giving my answer, is it in order for me to sell kilometers per hour?
No.
I convert.
Yeah, when the question is requires converting, convert.
Okay, sir.